We're going to talk about ergonomics, stance, and grip today. The first thing is obviously holding the chainsaw. You want to have your left hand forward and your right hand to the rear with thumbs wrapped around the handle so that you don't create a seam that the saw could kick out. You also want to utilize the thumb muscle, which is very strong, to help minimize some of the weight of the saw when you're running it. Ergonomics is a fancy word for a simple concept, meaning that we design the chainsaw to match the human body. If you look at the handles, they're at a 7-degree offset such that when I go to cut, it keeps the saw to the right side of my body, more out of the plane of my body, so there's less chance of impact. It also forces a boxer position, which allows me to keep the saw very close to my body, which is a lot safer. For every inch you move that chainsaw away from your body, it increases the load on your lumbar, and load creates fatigue via a chance of injury. So the left leg forward, the right leg receded, thumbs gripped around the handles, locked down. Chainsaws have 2 speeds, full speed and at idle. So when you're cutting, you want to run it at full speed. This stance also minimizes the reactive forces of a chainsaw. A chainsaw creates 3 reactive forces when you're cutting. When you put it down on the wood, the tendency is to move away from the operator. So your body anchors that so you're not using your muscle mass to do so. You don't want to be pulled over the top to where your left hand or something could get in the way of the chain. So this anchor position does really nice to anchor you in and defeat that reactive force. When you cut on the top of the bar, the tendency is to push into the operator. Again, you're letting the stance, your boxer stance, anchor that, minimize that energy. When you touch the top corner of the bar, that's the 3rd reactive force. We call that kickback. And we always want to manage that. We never want to touch the top corner of the bar. If that happens, literally the chain stops, to which the bar is thrown in the radius of the plane. A mechanical activation of chain brake occurs, and it gives you some reaction time to move the saw away from you. What's happening by that is as the saw comes around the top corner, you can see how much of a bite goes into the chain. And it stops the saw from running, and in turn, Newton, when he got beamed by an apple, figured out for every action of energy, there's an opposite and equal reaction. It's going to throw that saw in the radius of the plane that you're holding it. So the top corner here is going to create a mechanical activation. However, if you're in a felling position, that saw would stop and go. It's going to be winging out there somewhere around where you don't want it to be. So we've integrated what's called an inertia activated chain brake into this saw. When the saw is running, if you hit the top corner, it kind of mimics just dropping the saw down on the corner like that, such that it stops the saw. Inertia throws the weighted handle forward, and it's going to actually stop the saw from running. So as it would be moving away from the operator, it's going to be stopped and locked in, and a lot less chance of injury. As we talked about, this boxer position with a leading left leg creates a higher opportunity, if you will, for laceration or cut. So it's very important that we protect our legs. Legs are protected in different garments. This is what's called an apron chap. The fibers are comprised of different things. They can be ballistic nylon, which is the white fiber, or Kevlar, which is the yellow. This is a mix or a blend. The idea is that when the chainsaw comes in contact with the garment, the chain brake goes on right away because it's like a kickback occurring. The chain stops instantly, inertia throws the brake forward, and it gives you reaction time to move the saw away from your body. By the way, if you do ever have an impact to your chaps or pants or wraps, they are rendered useless. They're a good teaching tool because once they've taken a strike or a cut, exposing any fiber or any burn or any melting of the denier on the outside, they're no longer usable. A couple things with the chaps. You want to refer to wash and care instructions that accompany the garment. It's important that the fibers remain pillowy or poofy, if you will. As gas and oil and heat hits these things, they really get mashed down, and the effective stranding or the ability to stop the saw lessens as they get older. So as long as they're not cut, you can have these forever. You just want to keep them laundered to keep them a little bit poofy. It's not about aesthetic or the look of it. It's about keeping the fibers from getting gassy and oily and so forth. Secondarily, you want to look for UL classification. UL means that they were tested in accordance with standards that give you the maximum protection for the best value on the market. This is a pair of your basic apron chaps which run down the front of the operator's legs. It's a one size fits all. They clip in the back. The strap should be on and should be put tight to the operator, because when the saw comes in contact, if they're loose, it would have a tendency to turn the chap material and leave an exposed leg for possibility of cut or laceration. So these want to be on nice and tight, draw them up tight, and then you can take the straps and run them down the back of your leg, if you will, and they won't then grab onto the brush and so forth as you're walking out in the woods. The chap needs to come above your boot, if you will, and there are extenders built into the waistline of this so that you can make them longer or shorter, so they'll custom design to different body types and styles, if you will. Very important, because currently the left leg is the leading area for laceration or cut. Apron chaps, they run down the front. There's also protective chaps called wrap chaps, and they're the same as an apron chap. They run down the front of your leg, but they do clip on so that they give you a lot of protection on the lower leg around the bottom, such that if the saw were to come more in contact on the inner instead of the front portion of the leg, there is an added barrier of protection. And then the third means of leg protection is cutting pants. The pants I have on are like a wrap chap. They have material all around the leg to the front. They're very cool in the back and near. They're breathable. This is one size fits all, which is better for crew work or something. If I'm out in the woods all day long, this is a lot better situation for me. They're a lot cooler, if you will. Contrary to what you might think using a chainsaw, laceration is not the #1 injury that occurs. It's actually struck by. Things that come out of the tree as a tree is moving, or after a storm, there's a lot of lateral bind and pressures associated to the wood, and struck by or getting hit by wood, whether it comes down or comes laterally to you, is a key injury, the leading injury working with a chainsaw. So I have a protective hard hat here. The hard hat is made out of ABS polymer, which is the same material that we use on the chainsaws. Very strong, resilient ABS polymer, if you will, that gives you both impact protection and deflection protection. Now the hard hats do have a date code on the inside, tells you when they were made, but it's really what's important is how much exposure to the sun, because these dry out and they become brittle, and then they lose their effective protection for your head. A good way to check a hard hat before you go to work is just take it by the ears and squeeze as hard as you can and look for stress marks or splintering or even fracture marks in the crown of the helmet, and that tells you that my helmet is good to go for the day. A key feature of a hard hat should have a gutter system. The gutter system is such that it attracts the rain, pulls it from the back to the front of the operator, if you will, and then it drips down the front of your body instead of going down your back, following down your legs into your feet. Now you got cold, wet feet, and you've got distraction and loss of focus, and you got higher chance of injury as you're working. So it's a minor thing, but it's a big thing, having a gutter system on that helmet. This helmet system has hearing protection attached right to it. Hearing protection is extremely important because your ears are the only thing in your body that don't grow cells, that don't rejuvenate loss of cells. So you're losing hearing as you go, and mid-range sound of a chainsaw, of a lawnmower, is extremely hard on your hearing system. So it's important that you create a barrier to the noise. Noise is distracting. Noise creates fatigue, and noise in turn creates fatigue and in turn injury. So we really want to limit that. Now you have earplugs, which is one way of isolating that, but there's a lot of hearing that comes through the outer bone mass outside the hearing canal. So really a muff system like this is much better. Now if you're out cutting under a blue beautiful sky in the summer and you have nothing overhead, no trees, you're just cutting firewood, then a pair of muffs work perfectly fine for you. These adapt to all operators. They adjust up and down for different skull sizes. They also adjust so that you can put more pressure or less pressure to the side of your head as you're wearing them. So different skull sizes, these become very comfortable, and in turn, if they're comfortable, you're going to be more apt to wear them and wear them throughout the job. Glasses are not to be confused with face protection. You have to have some face protection. With the chips flying at you, you also want to protect your eyes for sure. Chainsaw glasses are unique in that they are 99.9% panoramic. That means that when you put them on, they do not distort the field of view at all, which in turn creates good focus and you don't have eye strain and so forth. There is a lot of problem with these fogging up on a hot July day, so there are nose vents that are in, so it dissipates the heat away from the inside of the glass, prevents them from fogging. They also are adjustable up and down and out and in again to adapt to many different skull sizes and so forth for each operator. They're available in dark, sunny days, or clear if you want to maintain eye contact, or in the afternoon or times of the day when sun is not a factor. It's your call. Protect your eyes. Gloves. You're working around a chainsaw, not only a laceration, but you want to create a barrier to oils and gases as you're working with the chainsaw. You don't want that getting into your skin and then getting into your system and creating some possible issues long term. Chainsaw gloves are unique in that they are very thin between the fingers. When you put them on, they don't spread your fingers out. And if you take your hand and spread it and squeeze your arm, then put your fingers together and squeeze, you can see that your grip strength is enhanced greatly, so you're going to use less muscle to hold the saw and turn. You're going to have less chance of cramping, less chance of dropping the saw, if you will. Chainsaws, gloves have protection on the left hand as well, such that if a chainsaw chain did come off, if it goes down below, a chain catcher pin will stop it. If it were to come up over the top of the saw in an application, you have some protection here that's going to prevent laceration or cut to your left hand. Boots are whatever is appropriate to the known hazards of the job. That's your call. Certainly working out in the woods, you want to have something with a firm sole so that your foot's not going over every little branch, because it in turn creates more fatigue to your feet. You want to have some ankle support as well to keep your ankles from turning, twisting, sprains, etc. that way. So whatever is appropriate to the known job hazards. So that's PPE, personal protective equipment, and that involves your legs, your head, your eyes, your face, your hands, and your feet. I want to talk a little bit about maintenance before we go to work. First thing I do with my saw is I like to give it a visual inspection. Visually, I'm looking for nuts, cracks, housings, loosened up bolts, those kind of things, leaking fuels, duct tape, anything out of the ordinary that shouldn't be part of the saw. I always like to tap the muffler before I go to work, because they get hot and cold and hot and cold. There's a lot of expand, contract going on, and they loosen up. So I might want to make sure that that's nice and tight. Fuel, you want to use 89 octane fuel or higher. Mix it to the ratio that it is stated as. 50-to-1 being 50 parts gas, 1 part oil. You don't want to mix it less or more. You want to mix it according to what the manufacturer's instructions tell you to do. There are also good canned fuels that are 95 octane that have the mix right in them, and they do not have ethanol, and they are a good source of fuel as well. Bar oil. Bar oil will go into the front of the saw. You want to use bar oil because, first of all, bar oil is delivered to the top saw through this hole here. As it goes from the top, it's carried around the bottom so that you get a lot of... Starting the chainsaw, the chain brake is always on. In fact, the only time the brake shouldn't be on is when you're cutting or when the chain is running. So the brake is on. The decompression valve, this has got a little valve on the top here that eliminates 40% of the starting effort, so we get less rope breakage and we get easier starting out of it. When you have a cold saw, you pull out the choke. This saw here, you pull out the blue switch and it raises the stop switch to run, which is a great feature. On other saws, you can refer to operating instructions. This particular one integrates the choke, the stop, and the run all into one switch, which is very handy. It right now is in a run position. To choke the saw when it's cold, I can pull out and raise it up. I can then pull it to get that pop start. Taking it down to the middle position is at high idle and run. And if I need to stop the saw, it just goes down to stop and immediately returns to the run position. So again, leg locking the saw or starting the saw from a standing position, chain brake on, the decompression valve in, the choke is out. I'm going to lock it under my leg, give it a pull, it will pop to start, but it won't run. Push the choke in, you can set the decompression valve again, give it a start, it will run, hit the throttle to lower it down to idle. There's 3 positions in the choke. Again, refer to your individual operating instructions. That is a leg lock start. The other start is to start the saw down on the ground. Notice that the bar pitches up away from the ground, the dirt and so forth. You can either put your toe in the strap, or if you got a big old steel toe boot, you can come around to the back side because the handle is wider in the back to protect the operator's hand, or you can put your knee on it and give it a pull. The bottom line is you don't want to pull and have the saw go into the dirt, because then when you start cutting, you're going to have dull chain. As the saw is started now, we want to let it warm up. We let it warm up by not only letting the motor run at idle, but we want to run it slightly with some throttle so that it is oiling, because this chainsaw has an environmental friendly oiler on it. It will not oil or pump bar oil out unless the chain is moving. So that way we have the chain going in that's lubricated into the wood for the cut, which lowers the heat and in turn improves the performance and the length of life of the chain. So after the saw has been warmed up, take the brake off. We want to run it up to full speed, full throttle, all the way down. And we want to listen for a sore throat sound, I call it, or a dieseling or four-stroking. You want the high speed to dance a little bit. You don't want it to be straight line. If I may, and a little bit of a jump in there, not straight or white line or too much air, which is too much heat. So that is a function of the H, or the high speed screw, to adjust that. Take your finger off the throttle after it's dancing at high speed, bring it down. Again, no movement of the chain. That's the T screw or your LA screw. And then with the chain brake on, you can actually rotate the chainsaw, which is a function of the low speed, to make sure it doesn't stall or stutter. Take the chain brake off and hit the throttle a few times. You want very snappy response up and very snappy response down. That tells you that the L, the low speed circuit, is adjusted properly. You want a saw to be adjusted properly for performance. I want you to understand that performance is directly in line with safety. You're going to be productive with high performance when the saw is running with those 3 circuits set appropriately. You're also going to be doing it the safe way. What's very exciting in new technology is a technology called auto-tune. And what's happening now is there are no carburetor adjustments, because the adjustments are all done with a very inexpensive microprocessor that magnetically controls the fuel and air, if you will, monitoring about 7 times a second. So as you change altitude, it automatically changes the performance of the saw to that altitude. As the chain dulls, as you have different varieties of fuel with different chemical compositions in it, or different formulas depending on the time of the year, it's going to compensate and adjust for that. It does it all for you. As the saw breaks in, it's going to automatically tune and adjust itself. Pretty exciting for very nominal cost, if you will. It's going to take all the adjusting out so that you absolutely are going to be sure that that saw is running at peak performance, peak productivity, and you're going to be very safe in doing so. I want to talk a little bit about notches. Now, I've drawn 3 pictures of notches on the board here. Why do you put a notch in a tree? For direction. Essentially, it's the direction of where you want the tree to fell. We have got felling marks or black lines on the saw or lines embossed in the saw all around the saw, such that if I want the tree to fall right up the middle, it starts by aiming your felling lines where you want the tree to go, if you will. That starts the first part of a notch, if you will, is direction. Do you understand this statement? If I say the notch is the front line of the hinge, do you understand what that means? Because if I've got a tree here and I have no attachment, if you will, to it, and the tree is leaning to the left a little bit, it invariably is going to go to the left, or leaning to the right, invariably could go to the right if I don't have an attachment point, like my elbow, to draw it exactly where I want it to go. So it's important that you understand that a notch alone is not, you're not complete. You need to have a notch and a hinge. Now, this first notch here is what you typically refer to as a standard, common, or conventional notch. It starts with a top cut into the wood about a third of the way, if you will, at a 45-degree angle. You then make the bottom cut. As a rule of thumb, you make the bottom cut with the lay of the land. In other words, this is on flat ground, if you will. This might be on steep terrain or hillside, if you will. So a minimum of 45 degrees. You want to cut this notch and create what's called a clean apex. You do not want to bypass the cut. In other words, where the top and bottom cut come together, that is the apex. That needs to be very clean and precise. You don't want to have the saw run underneath and create a bypass like that. You have to then go back in and clean that up so it's clean where they both cuts come together, if you will. Now, I'm not a big fan of the standard conventional notch for cutting on the ground, because essentially what happens is the tree gets to 45 degrees, and then what happens to my notch? Yeah, the notch closes, okay? So when it closes, it puts pressure on the stump or the stem, and it tends to seek the stump, and you can see you get a lot of butt rebound, or a lot of the butt end of the tree coming back off behind the stump. So rule 101 is never stand behind the tree when you're felling the tree. So to help you with this notch closing, because you don't want that tree to break at 45 degrees, because then it's going to go in the direction of the lean. It's not going to end up going where you want it to go, or it's going to sweep off the back of the stump, and that's not a good situation either. So what you want to do when you're making your back cut or your felling cut is you want to make this back cut from the back 1 inch to 2 inches above the apex, because that creates a stair step, or what we call a stump shot, so that as the tree is going, it tends to push on the back of this stump, and it keeps motion of the tree going forward. Very simple, the right thing to do. This is a Humboldt notch. It's a 45-degree standard notch upside down. It was developed in Humboldt County, California, primarily because of very steep slopes and felling trees on steep slopes. The other advantage of this when you're cutting big trees in Humboldt County, California, is that the notch wood on this conventional standard notch just sits on the shelf, and there was as much work, could be as much work getting that notch wood out. Those notches weighed 800 pounds, some of them, and up. So they made this upside down so that the notch would just slide out of the cut, and you didn't have to deal with all that extra work. Now the same rule applies, though I'm not as big a fan of this, is because the tree at 45 degrees, the notch closes, if you will. So you still have to create a back cut that is elevated the apex by 1 inch to 2 inches to create this stump shot, if you will, so that the back of the tree lodges on that, keeps motion going forward. This is the notch that I use almost all the time. It's an open face notch. It essentially takes a 45-degree notch and opens up the face to 70 degrees or more. The reason for that is that the tree then gets past 45 all the way to 70 to 90 degrees, which means the tree is on the ground before it creates pressure at the base, and it has more control. It allows the notch to work farther, if you will, as the tree is going, versus having it stop at 45 degrees. Now, this would be an open face notch. on level ground. And we actually have a nice design feature into the saw that way. When you hold the saw, it literally puts that bend of that blade at about 70 degrees. So all I got to do is hold it in the bend and aim where I'm cutting my notch, and then cut into the tree till I'm about 80% across the face, if you will. So this would show you that you're on level ground, if you will. The nice thing about this as well is you're cutting more down the front of the tree. You're not cutting as far into the tree, and which keeps the cut, if you will, more into the sapwood. Now, if you're looking down through the top of the tree down, this would be the notch that is cut out. You would cut this top cut until you're about 80% of the diameter of the tree, if you will. You don't want to cut to your 100%, because that means that that hinge wood is going to be all the way halfway through the tree, if you will. So we want it to stay out front, if you will, out of the heartwood, more into the sapwood, which is the strong living fiber, very, very strong fiber of the tree. So 80% across. That also keeps my hinge more into the sapwood, if you will. So that's your cut. If you were making the open face notch on a hillside, it literally would be just angling that bottom cut downwards, so that you match the slope of the terrain so that the notch face closes after it's on the ground down the hillside. Remember this as well, when you're dealing with trees that are leaning backwards and you got to pull them up and over or wedge them over or machinery or rig them over, however you use them to get them to go over top dead center, you must make that notch larger, because you could literally, by pulling the tree up, eat up your 45 degrees of notch, and the notch is closed and the tree is vertical. So you really have to have this opened up a lot more so that you can allow the hinge to work after the tree goes over top dead center. So you'd want to have that open this way, very similar to what you got down there. Now the nice thing about this is that you can make this cut now equal or elevated by 1 to 2 inches above the apex, which gives you some margin of error. It's a little bit easier to do, can show you outside. It's also a lot more helpful to use that when you're using big trees and making cuts from the back on the big diameter types of trees. That tree now gets all the way down to the ground, the hinge works all the way, the notch face stays open, and everything is good. We have direct control all the way down. Now, we've talked about the hinge. The hinge is the uncut wood behind the notch, if you will. So in my first diagram here, it would be something that looks like in this area here. This would be your uncut wood, because without a hinge, you don't have any control. It doesn't allow the notch to work all the way, the tree all the way down to the ground. So you must leave a certain amount of wood. The calculation for that hinge wood, if you cut from the back, whatever you're doing, you have to leave a certain amount of that. The formula becomes 10% of the DBH. Now, DBH is an acronym for diameter breast height. That's a measurement at 4.5 feet above the ground, because you largely get above the root flare up into what is the measurable part of the tree based on its age and so forth. 10% DBH. So if I have a tree here that's 10 inches wide at 4.5 feet above the ground, 10% of 10 inches is 1.0, 1 inch. So you'd want this to be 1 inch as it is, uniform to 80% the length all the way across the back. Now, the traditional way of doing this is to cut from the back until you get up there to your hinge size, chain break, and get into your escape route. We'll talk more about that later. What I propose to you is this. The hinge, to most people, is the most important part of felling a tree. So when you're cutting the tree from the back, you're setting up the hinge last. As opposed to, we talked about those reactive forces. If I try to go through this tree with the top corner, it's going to kick. But if I try to go through with the bottom corner, it'll allow the reactive force of pull on the bottom to go right through the tree. I can then go up and make my hinge, come to the back, and leave a little piece of holding wood here. That gives me added time to look at my crew to judge where they're at, or environmental conditions, or wind. I then just cut the back piece of that just prior to my escape or planned retreat, and I have a very, very good fell, because the hinge is made first, which is the most important part, instead of me cutting from the back to the front. We'll talk about this again. 85% or higher of injury is related to 15 feet to the stump. So if I'm cutting from the back to the front, I'm cutting directly under where I'm at. I have a very, very high incidence of injury. If I cut through the center, make the hinge first, leave a piece, I can extend my retreat, check my crew, check the weather. I can clip that piece and the tree falls very quickly, and I have great control because the tree hinge is set at the perfect size and set right at 10% of the DBH. So we have a tree that needs to come down, and it's important that we, again, speak in terms of a plan. And before you fell a tree, we want to walk down through the plan to get to step 5 and say, yes, I'm going to proceed because I'm competent and confident in doing so, or no, I'm not going to proceed and I need help, whatever that might be. So I want you to know that this is not a magic wand. It's merely a process to get you through to step 5 to say, yes, I'm going to proceed, or no, I'm not. If you look at my tree here, what would be the first thing that you do before you want to fell a tree? I mean, you come up to a tree here, the knees comes down. What's the first thing that you would do? Yeah, I mean, site analysis is good, or determine your hazards and obstacles, right? Hazard is something that can cause a problem to you. An obstacle is something that you can cause a problem to. In many terms and times, power lines, for example, are both a hazard and an obstacle. You want to determine hazards and obstacles in keeping to a plan that approaches this from a safe side or safe distances, as well as you need to have a place for the tree to go. If you're working out in the woods and you have nothing but trees, the only obstacle really you might have are other trees. You need to have a place where the tree will go. So hazards and obstacles assessment or site analysis will help assess where you want the tree to go. So if you look at my drawing here, you've got power lines to the left. I can't go that way. I've got a fence behind me. I can't go behind me. You want to take information about the condition of the tree. Does the tree have flare at the base, meaning a good healthy environment it's on? If it looks like a telephone pole into the ground, maybe there's been some excavation or something done that could be creating some factors to the health of the tree, if you will. Do you have cat eyes, holes, mushrooms, molds growing off the trunk? Do you have dead branches? Widowmakers, as they would call. These are the things that would come straight down as the tree moves. We want to make sure that you were aware and have taken information on that. How about wind? Can wind help you or hurt you? I mean, yeah, it can either or. Now, I don't disagree with you that when I come up to a tree, I want the tree to go in the direction of the lean. It looks like that tree is leaning a little bit to the right. If I can do so, and in this case, the wind would actually be helping me push it that direction. However, I have a house, it looks like, and I don't know, I'd still like to go that way as long as I knew the house or the obstacle, if you were, is far enough away. So you need to be able to take a good measure of height reading, and you can do it very easily by just picking a stick up off the ground. If you pick a stick up off the ground to read height, let's just say that I want to measure the height of this wall inside here with glasses on, of course, from your cheek out. You're going to make 2 sections of line. So from here to the end of my stick equals from here to my cheek, or to my eye, if you will. As I keep a 90-degree angle here, in other words, you don't want to change this to 120, you don't want to make it 45, keep it at 90, lowering your shoulders down to the base of the tree, looking at it here. When that is framed at the base, and when you look at the top, you can walk forward or backwards so that you frame the top of the tree at the top of the stick. That line sight going up forms the third side of a right triangle, and from that place where you're standing, that's where that tree will come down. Now remember, you're measuring to the bottom of the tree. If you cut your notch 3 feet up, then you're going to be 3 feet shorter, but it's always better to be shorter than longer in that calculation. So if you were to walk back here in this situation, and my back is on the house, and I've got this framed to the base of the tree, and that I still see tree above my stick, it's not framed at both, then I know that that tree is going to get into the house, and in this case, I cannot fell that tree to the house as much as I'd like to. So based on everything here as well, bees and deadwood,
You have wildlife considerations in some states. You want to be careful about those types of things. Certainly dead wood and bees can be a hazard because they're attracted to heat, vibration, noise, and the color. And that's everything that you've got going on when you're using a chainsaw, if you will. So in this situation, again, I can't go right, I can't go left, I can't go behind me. I'm going to go literally out here in front into this open field. And I'm going to say that that open field is directly out here in front of me down this aisleway here. You need to have a place where you want the tree to go first. A lot of people would say, look at the leans of the tree first. You want to assess the hazards and or obstacles first, because the tree can go a lot of different ways. It doesn't have to be just in the direction of the lean. You can do a lot of things with it. It's got to go into a place where it's not going to hang up or create problems to other obstacles. So that's where I want the tree to go. Step 2 of the process is leans, L-E-A-N-S, plural, because when you look at this tree, you certainly, from your view, can get an idea of the side lean of the tree. How to determine that calculation is from the spot that you've determined where you want the tree to fall, generally about 30 feet out, because you get a good trajectory or view of the crown. Is it going to hang up? Is it got a free flow of motion through the tops of other trees? From that point, literally look at the tree straight on and take your left hand to the furthest branch to the left, your right hand to the furthest branch to the right, and drop a plumb line down. Now, after you frame the crown, a plumb line is if I would shimmy up that tree and hang a little fishing line with a weighted line, that line falls straight down to the bottom, irregardless of the lean of the tree. It doesn't discriminate. So how it would look would be to the left and to the right, and then a plumb line. I just take one hand, move it over, and drop it straight down. So if you're framing from here to here, about middle is here. If you drop a line straight down to this point here, you would measure from there to the base of the tree, and I'm going to say that that is 2 feet of side lean. So you can tell that the tree is leaning to the right, and you know it's got 2 feet of side lean. That being said, is if I aim my notch on the saw, the felling mark on the saw, if I aim to try and aim it right at that X, I'm going to miss that X by 2 feet to one side or the other. Because what we've got so far is, even if the tree's leaning forward, it's leaning 2 feet to the left, and it creates a pivot. That line, that tree is going to fall 2 feet away from where I want it to go. So how we fix that is by aiming the saw not directly at the line, but aiming it 2 feet opposite of the lean. Then the tree is pulled that way and brings it right down to where we want it to go. So that's how you determine the side lean, but it's leans plural. So I ask you, is this tree leaning towards you or is it leaning away from you? And you can't tell because they're two-dimensional, if you will. You can look outside here and you can do side lean on anything, but I can't tell the front or back lean, nor can you. So you just simply move from that spot to 90 degrees adjacent either side and do the same type of calculation. One hand to the back branch, one hand to the forward branch. You got that frame now. Take one hand to imaginary point equicenter, which is going to drop a plumb line straight down. I'm going to say that that line comes down 4 feet behind the tree. So what does that tell me about my situation? It's got 4 feet of back lean. So it's leaning back quite a bit. So I got a situation now where the tree is back 4 feet, to the left 2 feet, to get it to go to that spot in the center. Okay? Leans, plural. Step 3 is the planned retreat, or what we would call escape route. If you look at this tree leaning that way, as it is moving, and it's leaning to the left, as it's moving, there's a chance, if it does break free from the base, there is a chance that this tree is going to fall to the left of where I want it. It's going to go to the side lean side of the tree. So that becomes the bad side of the tree. We want to, when we can, escape to the good side at a 45-degree angle to 15 feet, if you will, distance. It's not about how far you get. You don't need to, and rule 102 is don't turn your back on it. It's about getting to 15 feet and then making sure that the notch and the hinge are working and the tree is going in the right direction. You're not behind the tree, you're away from the lean, and you're on the good side of the tree. Okay? Your escape route or your planned retreat. Step 4 would be the hinge. Before we even get into thinking about this tree, we want to determine the hinge. Again, the hinge calculation is 10% of the DBH. DBH, diameter breast height, is at 4.5 feet above the ground. So I'm going to just measure that tree at 4.5 feet above the ground. If it is 20 inches diameter, 10% of 20 is 2. So we would want the hinge plan of our tree. Here's again looking through the top of it. We would want it to be 80% across the face, and we would want the hinge to be 10% of that diameter uniform all the way across. So you got to know, on a 20-inch tree, that hinge would be 2 inches wide, a little bit wider. On a 30-inch tree, 3 inches. On a 10-inch tree, 1 inch. Because too thick creates too much wood, and the leverage at the top as the tree is moving can create a snap and bind because the hinge is too thick to allow movement, but you don't want it too thin because you have to have it holding all the way down as well. It has to be right at that 10% DBH, if you will. So that's our hinge calculation. And then our back cut plan is step 5. And the back cut plan is once you've put the notch in the tree, you need to say, am I going to cut this tree from the back to the front? Or what am I going to do and what do I need? Now in this situation we've got side lean. We know how to deal with the side lean by aiming one way or the other to offset that amount of lean. And the front to back lean, that becomes another issue entirely. I mean, if you have a tree leaning back 4 feet and it's going that way, at a minimum, you have to pull this thing 4 foot an inch before it goes on its own. So if you have a rope in a tree, a good rule to remember is to have that rope at twice the length of the tree. You know how to measure the height of the tree. You can double that. You don't want a rope pulling that's too short for obvious reasons. And you also want to manage where that rope is set. I mean, too tall, you can get it into flimsy branches or crotches and pull the crotch out or break the crotch out of it, or it's not enough wood fiber to hold to pull it. And too low, you start losing your mechanical advantage. So you've got mechanical advantage up high, you lose it coming down low, so it becomes a game of you need to be not to the tippy top, but somewhere where you have a stout enough branch. Don't come down too low because you lose mechanical advantage, and that way you can get the tree to come over the 4 foot in this case for it to ride on the way down. Now that's the next point. If you've got a rope in the tree, you can pull it up to 4 foot and an inch. But if I aim my notch directly at the point where I want the tree to go, and this tree is leaning to the left, I can pull it up over top dead center, but that tree is going to go to the left now when I let it go, because you can pull it up, but as soon as it goes, it's on its own. You can't pull it fast enough and keep tension on it, enough pre-tensioned all the way down. It's going to go, you're going to lose it to some drift to the side lean, if you will. So what you have to do with the rope in this case even is, you have a rope tied in, you'd still, when you put the notch in the tree, you still angle that notch 2 feet to the right, because after you pull the tree or use mechanical advantage such as come along or winches or certain types of apparatus, it's on its own and it's going to go in the direction of the side lean. You're not going to have control all the way down because you can't pull it down that fast. So that's rope. A lot of people would say, how do you deal with the back lean? Well, you use machinery. Get the bucket truck. Well, you know, most of them get up about 25 feet. Say you've got a tree that's 80 foot tall, we'll say here, and we could measure that, right? I mean, if you got a tree that's 80 foot tall and with leaning 4 foot back and you can only get the bucket up 25 feet, I mean, you don't have much mechanical advantage, and that's where your rollover protection comes in, because a lot of times it just pushes that tree back over and on top of you, if you will. I like using wedges. Wedges are in the form of a polymer wedge, if you will. These are for felling trees. They create lift is all they do. They're not for splitting wood. They're polymer, if you will. If the chainsaw comes in contact with the wedge, it has no bearing on the sharpness of the chain. It's going to keep cutting sharp and everything's good to go, if you will. So I just use wedges. Now, my question is, if you've got a tree that's leaning back 4 feet and 2 feet to the right, we know we got to move the top 4 foot and an inch before it goes over on its own. You have to, as part of your plan, you have to calculate the segments of the tree, or you have to understand, you have to know how many of these wedges are you going to use to get that tree to go up and over. So let me just ask you, say you got a tree 80 foot tall, let's just use that. So you're going to put a notch in here, right this, and you're going to aim 2 feet opposite of where you want it to go to compensate for that side lean. Say the tree is 12 inches DBH at breast height, 4.5 feet. So right off the bat, you're saying that your hinge needs to be 10% of 12 or just slightly over an inch. 1.2 would be the exact, but it doesn't have to be that precise. A little more than an inch or about an inch, if you will. Now, there's all kinds of considerations that come into play regarding wood fiber, pine versus hardwood, all that kind of thing with species. But for the general rule of thumb, 10% of the DBH is going to get us to where we need to be. Thin enough to hold and move, but not too thick to where it's going to snap and break. So if the tree is 80 foot tall and it's 12 inches wide, the segment of the tree, a segment is nothing more than a square, the segment is based on the diameter at breast height, DBH. So if at DBH I have a 12-inch diameter tree, I have essentially a 12-inch imaginary segment that I'm dealing with in the tree. If you have a square, and this is 5 inches by 5 or 4.5 by 4.5, whatever it is, whether it's 4 feet by 4 feet, if it's square, if I push up on the bottom of this square, it moves the exact amount at the top of this square, wouldn't you agree? If I push up on this an inch, it moves 1 inch at the top of this wedge. So figuring the segment of the tree, I say it's 12 inches diameter. I got a 12-inch segment in that tree. My next question is, how many of these go to the top of an 80-foot tall tree? Yeah, 80 of them. 80 segments go to the top of that tree. So I want you to look at this. If I move this an inch at the bottom, and I'm using an inch because the wedge has a 1-inch shoulder to it here. If I get the wedge in behind the tree and move it an inch, I've moved that square 1 inch, correct? 1 inch. If I've got two of these on top of each other, and I moved the bottom one 1 inch, I moved it 1 inch, and I moved it 2 inches at the top of the second square. If I've got 3 wedges on top of each other, or 3 squares, segments, and I move it an inch at the bottom, it's 1 inch, 2 inch, 3 inch. So it compounds every square, it compounds an inch. So in other words, I would get 1 inch, 2 inch, 3 inch, 4 inch, 78, 79, 80 inches of movement at the top of that tree with just one of these little wedges. So my tree is leaning back 4 feet. That would be 48 inches. 80 is more than enough to get me to go over top dead center. Now let me just take that a little bit further here. This will help you. If you have a tree that is 24 inches wide, okay, now you have a fatter tree. Say it's 80 foot tall, 24 inches wide, 2 feet is the segment. Now I only have 40 of these segments going to the top of the tree. You with me? So I'm only getting 40 inches of movement at the top. If the tree is leaning back 4 feet, I'm 8 inches shy. So what we would have to do is we would have to double or stack the wedges. And remember, you never want to stack wedges this way because each wedge will work on itself. When you drive it, it tends to wedge one out and the tree sits down and could come over backwards. So when you use wedges to stack, you can put them at a 90-degree angle and put them into the back of your tree and run them this type of way, and they will lock in and they won't shift or move on you. Now you're getting 40 and 40 or 80 inches, more than enough to compensate for 4 feet of lean on an 80-foot tree that's 2 foot wide. Morning, beautiful morning, bright and early. We got a lot of work to do. Let's get at it. So I've got a tree that's got to come down, and in review of our plan that we talked about, first step is to identify hazards and obstacles. In turn, that'll give me a good place for the tree to fell without being hung up by other trees or not in the road, that kind of thing. We're going to then do the side lean, side to side and front to back, get my lean information. That will help determine my escape route side. Remember, 45-degree angle, 15 foot max, or to about 15 foot. And we're then going to do the back cut plan, which in my situation is always a bore cut. Now, we talked a little bit about that, but I've got a tree here with a lot of lean. I want to bore cut into the tree because the hinge gets set up first and release it from the back, and it's going to allow the hinge to work all the way down. If I just start cutting into a tree from the back with a lot of forward lean, then it has a chance to barber chair or split the tree. And what I mean by that is, let me just get a little green stem here. If I've got a tree with a lot of forward lean on it, and I just start cutting from the back and the chain's maybe a little dull or the saw isn't running as well as it should, now we call it chase the cut. You got to get in there and get it done, because as you start cutting in the back, the kerf starts allowing the top to move forward, and then leverage starts creating a bending action here in the back. And what happens is you don't have the hinge thin enough, quick enough. It's very thick. It doesn't allow it to release at the base. It creates pressure up here to where the tree will, what we call barber chair. And in the old day, you had, as you keep bending this, it actually splits, and then the tree seeks the stump, so to speak. Very, very dangerous, because you're down here focused to the cut, the back cut, as we're talking about, and you're not aware of what's going up ahead. You also are going to have a severe productivity loss, obviously, with that, and dollar loss if you're cutting the tree for boards. It's dangerous, it's not productive, it's not the right thing to do. So I'm going to use a bore cut for sure as we finish up the back cut plan on that. So let's take information. If you pick a stick up off the ground to read height from your cheek out, you're going to make 2 sections of line. So from here to the end of my stick equals from here to my cheek, or to my eye, if you will. Lowering your shoulders down to the base of the tree, looking at it here. When that is framed at the base, and when you look at the top, you can walk forward or backwards so that you frame the top of the tree at the top of the stick. That line sight going up forms the third side of a right triangle, and from that place where you're standing, that's where that tree will come down. And as I look out here, I get a little bit better view of my surrounding. I've got a clear base. We've got other trees that become the only obstacle I'm dealing with for the most part. I got a vehicle in the back. We've got a little tree, some protection. The ground is good. The wind is not bad at all. The condition of the tree has some flare to it, which is good. So we do have dead branches as we go up the tree. I do have a dead one off the back here I want to be concerned about. It could be close to an escape route if I go that way, but I certainly want to stay to 45 degree, and I'll avoid that limb up at the top. So at about 30 feet out, I'm going to take information on the side lean. I'll take information with my back to that point. It's important that you take information with right in line of where you're working, because if you change the angle, it's going to change the direction. If I say I want that tree to go up by that spud, and I do my side line here, right, left, get the crown frame, drop a plumb line down, I get 3 feet of side lean here, where in this position, I actually right, left, drop a plumb line down from the center point, I actually have a straight tree. So we're going to aim directly at the position where we want that to go to that tree. From here, and you guys can see out, trees are two-dimensional out here. I can tell the side lean, but I can't tell if the tree is leaning forward or back. So I'm going to go 90 degrees adjacent and take the same information. From here to 90, right hand, furthest branch to the right, left hand, wow, that branch is way out there. We know we've got a lot of forward lean. And again, that's where that bore cut comes into play. I want to set up the hinge first to have the hinge the right size, and that will not allow the pressure to build up and leverage to create pressure at the base, at the stem, so that the hinge and the notch will work all the way down without fracturing. So pretty good to go on that respect. All your notches are cut on this side of the tree, and I'll be in this position here looking down the felling mark. Now, where exactly do I want to cut the notch? Well, what exactly are you cutting a tree for? This is pretty much going to be firewood, or it's just going to be left naturally in the area here. So I can cut the notch wherever I want. If I'm doing it for boards or something for a value, I'm going to cut it way, way down low, maybe to preserve that dollars in the wood up above. I like to, if I had the choice of firewood cutting a tree, I like to work right off of this position, having the motor of the saw or the back handle on my leg. That way it positions my body so I can get behind the saw. Real important that I look down this felling mark, because if you're standing here like this looking, you can't tell. You've got to, it's a little bit of a difference, but you got to get way behind it and look down the saw. Again, I'm going to point right to where I want the tree to go. Now, if the tree had 2 feet of side lean to the left, let's say it's leaning to the left, and I aim where I want it to go, and the tree goes down, I miss my mark. So what I do to compensate again is I would aim not where I want it to go, but I would aim 2 feet offsetting that. So as I aim this way with my notch or my felling mark on my saw, the tree goes and brings the point right to where I want it to go based on offsetting that aim on my saw. Okay? So in this case, I'm going to cut this notch about right in this area here. If I'm on this side, all your notches are cut on this side because the saw is designed to look down that felling mark. You can't do it from this side. You can't get to a position where you can see the line, so all notches would be cut on this side of the tree, and then you would want to get on the other side or on the side that you're escaping to, retreating to, because we don't want to be going back across the back of the tree. So I'm going to put the notch in on this side. The first thing I say is, what do I have at 45-degree angle, 15 feet of the stump? And I've got some brush I got to clean up, obviously, as part of my assessment. So I'm going to clean that, and then I'm going to go right downhill here to 15 feet. I'm good to go. That way I can do all my work on this side of the tree. Okay, so I planned retreat. Next part of the plan, step 4, is the hinge calculation. And remember, we come up at 4.5 feet above the bottom because we want to get above this flare. If we measure the tree down below here and it's 40 inches, and I come up and put a 4-inch hinge in this tree, it's too thick and it's going to build up pressure, and we could have a barber chair situation, or maybe the tree doesn't even go readily, and now we got cutting and more things going on. Very dangerous. So I want to come up at 4.5 feet, and when I measure that tree, it comes out at 4.5 feet across at about 15 inches. So remember, our hinge calculation was 10% of the DBH, or about 1.5 or 1.5 inches is what I want for a hinge. Whether you cut from the back or you bore cut, you want to always have that hinge. You have to have that hinge size in there. That's the optimum size to hold the tree, allow the tree to work, and the safest way to do it. The hinge is the most important part of this plan. Step 5 is that back cut. So I'll be over here, and we're going to bore cut through the center of the tree, move up, make my 1.5 inch hinge, go to the back, leave a little piece. It'll allow me to reposition, check the wind, check all you guys, make sure things are safe, nobody's coming up and down this road, and then I'll release that back piece. So step 5 is designed for you to say, yes, I'm going to proceed, or no, I'm not.
and I feel confident and competent in what I'm doing here, so I'm going to say I'm going to proceed. But there are many times, gang, that I get to step 5 and say, nope, I'm going to walk away from it. I need rope, I need rigging, I need help, I need machinery. I could just say it's a situation for an arborist to loft, and I walk away from it. I'm going to proceed with my plan on this situation. So let's get the saw started. Chain brake saw was on. As we talked about, you can start it on the ground with your toe through the stirrup, or your heel in the back, because the saw is wider to protect your hand, or I could kneel down on it. Remember that the saw bar does pitch up to keep it out of the dirt for you if you are starting on the ground. The second way to start it, chain brake on obviously, is to leg lock it. Put it under your knee, because the rule is, and the right thing to do, you don't want to have any movement of that bar while you're cutting a tree. So I'm going to lock this in, lock my arm out, and I'm going to give it a tug and lower the idle down. I want to let the saw warm up. I'm going to do that by idling here, and then I want to give it some motion, because this is an environmental friendly oiler. I want it to oil, and it does oil when the chain goes around. So we got oil coming out, we're good to go. I then want to do that performance check. So I'm going to take the saw up to full speed and listen for that 4-stroke or dieseling or sore throat sound, if you will. That controls the H, the high speed circuit, or the H screw on a normal adjusted carburetor, if you will. So I'm going to take it up to full speed. You can hear right away that it's got that dance or that little sore throat sound. It's not leaned out too straight or flat line, so we're good to go. I don't have any movement of the chain at idle. That will be the T circuit, the throttle circuit. And then I want to roll the saw right, left. It doesn't stall or stutter. And I want to hit the throttle, make sure it's very snappy up and down. So we're good to go. Now, on my notch, I'm going to use an open face notch. We talked about those 3 notches. You have a standard notch, 45 degrees, very deep. The bottom cut's level with the lay of the land. You have the Humboldt, which is upside down, if you will, so the notch would slide out. It also created a step back cut, so the tree doesn't kick off the back as readily. And if you combine the two and open it up to 70 or more, you get an open face notch. The open face notch, to me, is preferred, because instead of the tree stopping at 45 when the notch closes, it allows the hinge to work all the way to the ground, or about 70 to 90 degrees. So that's what I want. I want that notch face to close once I'm on the ground. Okay? So we'll put an open face notch in it. First thing we want to do is clean up that brush, as we talked about. I'm going to get this axe somewhere where it's readily available if I do need it for anything, but I don't want it exactly in my escape route. Chainsaws have 2 speeds, idle and full bore. You have a lot of control, it's very smooth, less vibration when it's running at full speed. So I'm going to position my body here. The chainsaws are built a nice, comfortable hold in the handle so that it gives you that 70-degree pitch automatically. It's also nice and level. We want that cut to be level, because when I make this cut here, holding it level will allow me to match the bottom cut much more easily. So I'm going to hold the saw here at 70 degrees. I want to sight down to where I want the tree to go, and I'm going to start my cut. But I'm not going to look at what I'm doing. If I say this is where I want the tree to go and start looking at what I'm doing, I've just changed the direction of the cut. So I want to stay in here focused so that the line is going right at my marker out there until the saw gets bit into the wood.
Okay, so let's get that part done. Now that the saw is into the wood, it will not turn on me. So now I want to focus to being 80% across the face of this tree for my hinge. Check to make sure I'm 80% across the face, pretty close. From here to here, it could be just a little bit more work. So my tree diameter from here to here is 100. From here to here, oh, about 80%. I think we're good to go. So we're gonna now make the bottom cut. With the lay of the land, it's pretty level here. So I literally, because I made this cut level, pull the saw, rotate it again. We got another good balance point here. It's easier to start on one corner and match the other than start out here and have to match two. So because I've leveled the cut, if I start level, I'm gonna swing around here looking through the curve, cutting to when those cuts match. I don't want to bypass that cut. That'll put pressure on the trunk right away when the tree moves. So we have our 70-degree open face notch, about 80% across the face. We talked about cutting so that you have a clean apex where the top and bottom cut come together. You want that to be clean. Now, this is fine. I wanted to leave just a hair bit of this to show you that if this cut goes down or in further than the width of the chain, which is 3/8 of an inch roughly, then you've got too much bypass. You got to clean that up by taking the bottom or recutting both sides of the top cut to get that to be perfectly clean. Because the cut is not deeper than 3/8, either down or in, which is wider than the chain itself, this cut is perfectly okay. And as you can tell, it's going to allow the tree to come down. The face notch will close on the bottom cut. It won't close in the kerf or this bypass, which again is very dangerous. So we're ready to start our back cut plan, which is mine is a bore cut. And remember, we want to review what we talked about earlier about reactive forces of the saw. When you use the bottom of the bar, the tendency is to pull away from you, and again, that equates to a good stance, be anchored down, good terrain, nothing there that's going to create trip hazard or pull me over or snag me. On the top of the bar when you're cutting, it's going to create push into your body, and if you touch the top corner of the bar to wood, it's going to kick very violently. So to go through the center of this tree, because I want to set up my hinge first, not cutting from the back, I don't want to start with the top cut. I actually want to start with the bottom of the bar, and as it bites in, you'll see I'm going to allow the pulling chain on the bottom to pull me right through the tree. I don't want to bore cut in parallel. I really am going to angle back slightly away from the cut and then come up. That's the beauty of the bore cut. It gives me time to set that hinge perfectly first in my back cut. Pushing chain, so I like to anchor my body on the saw so I save energy. It's going to tend to push back as I'm using the top of the bar. An inch and a half, pretty darn close. Setting the hinge up first with a bore cut. And remember, the chain brake should be on at all times other than when you're not cutting. So when you're pulling the saw out, you want to make sure that chain brake is on. Because the tendency is when you pull, you hit the throttle. If you're pulling out and you hit the throttle, the energy goes to the top corner, it kicks in the radius of plane, it's going to kick right into the hinge, and you can cut that hinge off. If the hinge is the most important part of the plan, that chain brake needs to be on before you pull that saw out. So we've got our hinge set perfectly to 1.5 inch. We now want to cut to the back, leaving holding wood on the back of the same dimension, 10%. So that'll be about 1.5 inch at the thickest part holding in the back. Remember, the bark does not count. So we've got a tree here that's got a little bit of bark, about 1/4 inch. I want about 1.5 inches of hardwood in the back, and I want to leave that holding wood on the good side of the tree where I'm at. I'm also going to tap a wedge in. No harm, no foul. The time to find out you need a wedge is before it's sitting down on your saw. So we've got the tree set up with our back strap now on the back, which is 10% of the DVH, just like the hinge. 10% of 15 would be 1.5. So we want to have an imaginary line going across that exposes 1.5 inches at the fattest part that is hardwood, remember. We don't want the bark, that doesn't count, it's very weak fiber. Now I could have, as I was cutting to leave this back strap, after the hinge was set up, cutting towards the back, could have just cut out. But I don't like that because, as we mentioned, 85% of injury occurring within 15 feet of the stump. If I cut out, that tree is moving and I'm right on the tree. That's a bad position to be. By bore cutting, I set the hinge up first. I come back, leave that holding wood. It allows me to position my body about 4 to 5 feet already away from the tree. Every foot counts. It also gives me a chance to recheck my crew, check conditions, no wind, nobody coming down the road before I proceed. It's the last chance to stop the plant. All clear, tree coming down. Before I come into the area, I want to make sure nothing ahead has been hit or come down, springs back, and then I want to give a command, all clear. We're good to go to come into our stump. So if we take a look at our stump, there's a lot we can tell about our plan as to if things went well or if we had some difficulty. The first thing you can see is that our hinge here is 80% across the diameter, roughly 80% the diameter of the tree. Now we focused 80% because if we went to 100%, the hinge goes all the way across the middle, which incorporates a lot of the heartwood of the tree, which is the dead fiber wood, which doesn't bend as readily and doesn't hold, it's not strong, it's brittle and it breaks, if you will. So we got our hinge at 80% and we've got it running in the sapwood, good strong wood fiber, if you will. The other thing we've got regarding the hinge is we said we wanted a plan on our hinge for 1.5 inches, and that is right at about 1.5 inches, and that is right at about 1.5 inches. So we're pretty uniform, and again, that bore cut allows me to go in and set the hinge up first instead of me trying to cut from the back and race and set the hinge up as the tree is moving. So it allowed me to get my full 1.5 inches and my 80% diameter. We also had an open face notch. As we showed you, the notch face was opened to 70 degrees or more, which allows the hinge to work and the tree to get to the ground before it puts pressure and breaks this hinge. We also can look at fiber tear off of the hinge. If you're tearing huge amounts of fiber, generally that's an indication that the hinge was too thick for that particular diameter of tree. It tears also sometimes a little higher, if you notice in the center here, than on the ends, because this was just at the edge of the heartwood. Again, that doesn't want to bend as readily. It wants to break and split, and that's what you see, the back of the split going up off of the hinge.
We also have a nice elevated apex here, and again, we want that to be equal or elevated no more than 2 inches. And the reason for that back cut being elevated slightly is that as the tree is falling, it pushes back on this stump shot or stair step, if you will, and it keeps motion of the tree going forward such that it won't slip off the back. We've also got a nice holding piece about 1.5 inches at the back of the hardwood only. So I'd say this stump checks out to being a pretty good score, and it did give us a good result. I'll tell you what is a good result is I'm safe and you're safe.
Nice.
All clear, tree coming down.
So now that the tree's down, we want to limb and bucket. Limbing and bucking is merely taking off the limbs flush to the trunk, and then we want to buck or cut it cross sections for whatever our use is. And this tree is just going to be for firewood, so we can make those cuts at any lengths we want, really. We're not subject to cutting it for boards at 16 feet or anything, so we can pretty much, we have a lot of flexibility with that. We first want to look at the ability for this tree to roll or twist. That would determine work position inside. I think if it had any ability at all to go anyway, it's going to the right, so I like being on the left, but generally with this pine, the branches are anchored in, it's pretty stable. I also want to look at the back and forth pressure from the stump to the top of the tree canopy, and it looks again that it's pretty anchored by the branches. We're on a little bit of a slope, but not much, and this will have the ability then to hold itself without shifting. We then look at up and down pressure, because we always want to make our cut starting on the compression side and finishing on the tension side. And we have gravity and we have a tree here, so we definitely have that. So I want to cut these branches off first here, because there is no pressure to them, and we'll get up further and then we'll have another discussion about compression and tension cuts. lot of pressure on that. Okay, so we're doing okay, but I want to show you something up here. We've got these two branches which are under severe bind, compression on the top side over on this other side of the tree, and compression or the tension, excuse me, on the side closest to me, and those are very dangerous situations. I'm going to move to the other side of the tree and we're going to show you how to deal with that. So as we talked about, we have a lot of compression here. That branch can bind down on the chain and bar very quickly, faster than I have reaction time or response. And that's what these cuts are about. Mismatch cuts are about giving us time to analyze the pressure and time to before it binds on the saw. So what I'm going to do is, in the compression side, because we're always starting on that compression side, instead of using the saw to cut directly into the branch, which can bind very quickly, I'm just going to shave up on that side, taking little bits of wood off at a time until a point where the pressure of that branch exceeds the strength of the wood to hold it, and it will break at that time without shattering, and then I can finish the cut. Let me finish off these branches back here too. With these spring poles, I still want to secure myself a good escape path at a 45-degree angle in case I got to go somewhere. Okay, so we're going to start shaving this on the compression side. We want to do this slowly, little bits of fiber again, so the pressure gets to a point where it exceeds the strength of the wood. See the movement? And there we go. You can see how much pressure. We've taken all the fight out of it. Now we can go to the tension side and release that safely. Want to have a good area footing wise. And we want to repeat that process. So we relieve the pressure by taking away the wood fiber slowly and let the pressure work against itself. So I want to finish limbing going up the tree here, and this limb here, while there's not a lot of weight to it, but it looks like it's compressing on the bottom. So I'll make that cut on the bottom, a third, read the kerf. You know, if the kerf doesn't collapse,
I could literally keep going, but I like to offset that cut or mismatch the cut, moving closer to the stem about an inch, because that's going to give me an idea if there's pressure at all on any of these branches before I finish the cut. And that way it doesn't spring off back to me where I might step back, stumble, fall, roll over some of these branches. I have a little bit more control using 2 cuts, starting on the compression first, finishing on the tension about an inch to the stump, and not matching the cuts but mismatching, moving over an inch. So that's the plan here. There is no weight on this branch, so we'll pretty much cut that off in these 2. Prime example, I don't want to walk by this to go cut this branch, because if this tree does roll, this becomes a very bad potential hazard for me for sure. When I get up to this branch here, really tough to read because it's in the ground pushing. Can't tell if it's pushing up, heaving, creating compression on the bottom and tension on the top, or if it's creating compression on the top and tension on the bottom. So I'm going to start with a cut on the bottom and read the kerf. Remember, if the kerf collapses, starts collapsing, stop, because I am cutting on the compression side of the wood. Move over an inch, mismatch the cut from the tension side. Always finish on that tension side where the kerf is opening up. Right away when I start this cut, the kerf starts to open up. So there's definitely compression on the top. So I'm just going to read this kerf. As long as it's opening up straight down, I know the movement is down, I'm good to go. If that cut started to close right away, again I move closer to the stump by an inch and offset that cut. A lot of pressure on this one. I can see too that the branch is coming back this way a little bit, and now I can see that it is rolling away from me. Great example there. Made the cut on the tension. It didn't move, didn't think there's any pressure. When I come back on the top though, it did start to compress when I mismatched the wood fiber. When all those fibers are cut, even though they didn't match, it exposes its hand. So I'm now going to go back into the tension side where it would have pinched. I'm now going to cut through the branch safely without creating a pinch hazard on my saw, which then in turn could create a hazard to me. So I've got my branches limbed up to this far, and I want to talk about compression and tension cuts. Now if you look at this tree, gravity is pushing down on the top of this, so I believe it looks like it's compressing on the top, if you will. If this were a table with legs pushing down on it, gravity is creating compression on the top and tension or stretch on the bottom of the fiber. So I want to cut into this until the kerf, which is the width of the cut, starts to close. I'm going to stop, pull the saw out. I'm going to put a wedge in, which will occupy the kerf, and I'll go back in and finish that cut, or finish from the tension side, if you will, cut up until we get a clean cut on that. Remember that you always cut the compression first and finish on the tension, or the tension last. The tension fiber last. Compression first, tension last. Kerf starts to close. I can take a wedge, knock it in. I could either come out and finish from the tension side, or since I've got that kerf occupied, I can continue to cut. It won't get pinched. Another use of the wedge is we talked about the bar angles up, and it matches the contour of that. We can use that wedge as a barrier underneath the tree. I could pound it in with my axe and make that cut over the wedge so that if the saw does come down into the dirt, obviously you have a barrier of a polymer wedge which does no damage to the chain at all as protection. I also can use the wedge as I buck this, since the bar is angled up. If I cut down to the heel of the handle and down so that the motor is flat on the ground, I still leave some hinge wood uncut at the bottom. I'm then going to put a wedge in the top of that cut and hit it with an axe, and you'll see that it puts taper on both ends. It's going to lift that wood up right up off the ground where I'm cutting, and then I can finish the cut naturally with airspace, not into the dirt, so I'm not going to dull my chain. Making this cut, I'm always looking at that curve. Starts closing, I want to stop, move to a different side. So I finished my cut without pinching and in the airspace without getting the bar and chain into the dirt, so I don't have dull chain. So another cut we can make to help expose the pressure so that I can get in a better work position, a better side on the tension side away from where the wood is moving, would be a tongue and groove cut. And this cut is going to be one that I bore cut through the center. I'm going to come to the top, I believe this is again the compression side, cut about a third or until I bypass that first bore cut, and then I'm going to finish the cut on the bottom, always looking at the cuts that I make, because if those cuts collapse on my side, I know the movement of the wood is that way, I'm a good side of the wood to finish. If it opens up on top, I know I need to extend my distance, not to get my chin or anything up where that wood could spring. If it opens up on the bottom, then I know it's moving down. Again, I want to make sure I'm on the uphill side, which I am, and I also want to make sure that I don't have that wood coming down near my feet or anything that way. So first thing I'm going to do is bore cut right through the center. Okay, I'm then going to make a compression cut on the top. Finish with a tension cut on the bottom. And because those kerfs did not change, there's pretty much equal pressure on this. In other words, now that we've taken all the weight off down yonder, it's pretty much sitting, I believe, on these branches. So at this point, I can go back into probably the bottom side here where it is tensioning where I originally thought, and finish the cut. Let me show you a little bit more about what that looks like here on this part that's elevated. I bore cut to the center, make a cut, compression, and make a cut on the tension side. And you can see that all three cuts have severed all of the grain fiber in the tree. And that would expose the pressure if there is any. Obviously there's no weight here, but if this center kerf collapses
and it's opening on the other side, I know movement is moving away from me. If this starts opening up, closes on the other side, I know it's coming at me. If this one opens up, I know movement is up. If this one opens up, I know movement is down. So it gives me opportunity to move, reposition myself to make a cut away from where these branches may be flying. Good. So it's called a tongue and groove cut because it obviously looks like tongue and groove, like paneling or something. Again, what we've done is we've severed all the fiber through the tree, and if there's pressure, that pressure is going to go to those curve cuts, and it's going to show me where the pressure is and where I need to stand so I can make that cut safely. Well, we started out today talking about accidents being planned events, and we talked about a lot of planning processes. We worked those plans, we were competent as we got to the last step, and we implemented them. We had a good day at Stark. We got quite a bit more work to do, but boy, you know, fatigue leads to injury. That overwhelmingly happens this time of the day, so I know my limits. I'm going to get up bright and early in the morning and start up again. Had a great day. Here's how I look at it. I'm safe. You guys are safe. Down the road, be safe out there.